Onward to our next session, we now have Mr. Siddharth Ajmera, a full-stack JavaScript developer who is also an author of 2 courses at Udemy with over 32,000 students, here to speak on the topic of Ivy for the win.
Okay, so as the title of my talk suggests, I'm going to talk about Ivy, and I hope you guys weren't sleeping when Minko was talking about Ivy in his slides. So it's not anymore a valid question whether you guys have heard about it. But have anybody of you used it earlier? Anyone? No? Yes? No feedback? Okay, no problem. So the agenda of this talk is to first let you know about Ivy, how Ivy works under the hood, and probably what all are the advantages of Ivy. So before we start, let's get the boring stuff out of the way. Ayubowan, is that how you say that? Ayubowan, Sri Lanka. My name is Siddharth Ajmera, and I'm a full stack JavaScript developer. And I'm also a Google developer expert for Angular and web technologies. Just in case you might want to reach out to me, this is my web handle, and I'm available almost anywhere on the web with this handle. So come say hi. All right, now the Angular part of our application can be broken down into two major parts or two major pieces. The first one is the code that compiles your Angular's abstractions to make it run on the browser, because browser doesn't really support or run TypeScript, right? So you need the Angular compiler to compile your templates basically into ng factory files, and then you have the code that you import from the Angular libraries themselves, like the code and platform browser, to support your Angular applications at runtime. And this is called the runtime. And together, the Angular compiler and the Angular runtime form something that's called the Angular renderer. And the Angular renderer is responsible for doing quite a lot of things. So here are a few responsibilities of the Angular renderer. It's responsible for transforming the Angular abstractions. So you might be using abstractions like the component decorator, the directive decorator, and all these decorators of sorts. It transforms them into JavaScript that actually runs on the browser. And this is something that you guys might not want to do because you guys cannot be as optimal as the Angular compiler itself. Then we have things like creation and manipulation of the DOM. This is also something that you might not want to do. Then we have things like data binding and change detection and creation of CSS and animations. So these are all a few responsibilities of the Angular renderer. Now Ivy is, as Minko said, Ivy is the third generation of Angular's compilation and rendering pipeline. Wait, third generation? What about the first and second? So as it stands out, in order to understand how Ivy actually works, you need to have a good mental model of how it used to work in the past, in the first and the second versions. So that's exactly what we are going to do now. We are going to understand how Angular applications used to work with Angular 2.0 to 4.0 to now. And with Ivy, how they are going to work in the near future. So to do that, we are going to examine a very simple Angular application. Now this is not as simple as a rudimentary hello world example. There's a lot more that's going on here. There's a string interpolation syntax, child component, and it's optionally rendered using the ngIf structural directive. And this is basically the code that's quite often used in most of the Angular applications. So we are going to examine this template, and we are going to do that using the previous two generations and see how Ivy is different and how Ivy implements it differently. So the first generation. Now, does anybody have an idea of what it was called? The first generation? No, it wasn't called beta. It was called the template compiler. And the template compiler was something that was introduced as a part of Angular 2.0 sometime around September 2016. And what it does is it transforms your HTML templates to JavaScript to both render them and detect changes on them at runtime. And as Minko already said, as of now, there's an ng factory file as well that gets generated, right? So for the components and for modules as well, there's an ng factory file. This ng factory file is responsible for essentially uh, representing your templates. So whatever template you have is eventually converted into a view definition or some rendering operations of sorts that eventually renders the DOM and detects changes. And Angular team did some benchmarking tests, and Angular team was able to determine that the way this was implemented, it was one of the fastest way to efficiently render things to the DOM. So I have an Angular 2 application running here, and I've opened the ng factory file for the app component. This is what the generated code looks like. Now you don't really want to like exactly understand what's going on here, but to get a general idea, we can see that there's a div and a span getting created somewhere by the calling of renderers few methods like the create text and create template anchor and all that. We are also able to see that there is an ng if somewhere getting generated here in this line somewhere, right? So this is how the code looks like. Now, as far as we talk about the pipeline of how this thing works, there's this template that you provide to the Angular compiler. The template is converted into template instructions, and these are implicit calls to the renderer, as you can see right here in the code. So we are calling renderer.createText, and there are some other methods being called on the renderer, right? So this template instruction is then going to generate the DOM for you, and we have already seen this code. This is a shorter version of this whole, but this essentially is responsible for rendering and change detection. Now there's an issue with this code though. As more and more developers started using Angular and they started building more and more complex user interfaces, they came to know that the generated code is quite verbose in nature. And this verbosity also adds to the bundle size, because as more and more verbose code is there, it's eventually going to also increase the bundle size, because more and more such code needs to get created or generated to render things. So the issues were that the templates which were generated by the Angular compiler were very verbose, and then this also resulted in large bundle sizes. So the Angular team took this feedback and they started working on a way to represent templates in a different way. And that's when they came up with the second generation of compilation and rendering pipeline. Now I'm pretty sure you might know what this is called, because this is something that Minko mentioned in his talk, or else you guys were sleeping. Yeah, I guess you guys were sleeping. So it was called the view engine, and this was introduced as a part of Angular 4, and this works a bit differently. What it does is, instead of making the implicit calls to the renderer, the templates are transformed into some sort of a data structure. So you now know, you now don't have any more rendering instructions directly, but there's a data structure, and then there's also a runtime component attached to it. What this runtime component does is it traverses this data structure, and then it determines whether it has to render something or it has to detect changes. And with this particular approach, without actually compromising with the performance of your applications, the Angular team was actually able to generate smaller structures and more optimal way of building your applications. So this is the generated code for Vue engine, and let's compare this with this code right here. This is generated by the template compiler, And as you can see, it's like around 117 lines of code. This is doing the exact same thing as this code is going to do, and it's just 29 lines of code. How cool is that, right? Now, how this works in the pipeline is there's a template which gets converted into template data or the data structure. And then this data structure is read by the Angular interpreter. This Angular interpreter crawls through the data structure and then detects changes or renders things to the DOM. And this is a more shorter version of that same code. Now, as you can compare this, it's definitely a lot smaller, which would significantly reduce your bundle sizes. But then there's also some issue with the code that gets generated here. As compared to this one, you cannot really determine what exactly is going on here, right? Like you can still get the general idea that there is a div and a span and an ngIf getting created here, but that's all you can see. There's a lot of magic numbers and a lot of nulls going around here and there in the generated code. The reason why that is because it wasn't really designed to be human readable, just like the code that was generated by the template compiler was. It was generally designed for the Angular's runtime to determine what it needs to do. So one of the main issues with this is it's not really human readable, and it's quite a lot cryptic, and it's also extremely difficult to determine what exactly is causing some issues when you run into one. Another issue is that on this particular line where the ngIf is getting created, there are two things that I see here. That's the view container ref and template ref. Now, does anybody have an idea where these two are coming from? Nobody? Okay. So these two are apparently the dependencies that ngIf has. So ngIf depends on the view container ref and template ref to generate itself. What we are seeing here in the generated code is that the implementation detail of the dependency that you are actually using in your templates is being leaked in the generated code, which is not really nice. What this will do is this will trigger a global compilation, because at the time of compiling app component, the compiler wouldn't really know whether the implementation of ngIf changed or not, and that's because of this implementation detail leak. So it's harder to understand. The implementation detail is leaking, and since Angular is going to trigger a global compilation, the this is going to result in slower builds and slower compilation speeds as well. Now there is one more issue with the view engine that we are going to talk about, and that is this template data structure that we have here that gets generated by the view engine is going to run through the Angular interpreter, right? So this is a pseudo implementation of the Angular's rendering engine. This is how it would look like if you implement it in a pseudo manner. So you can basically consider it as a very big switch statement. It interprets opcode by opcode the code that comes to it, and then it determines what exactly is the type of definition that it gets, whether it is an element definition, whether it is a text definition, whether it is a directive definition, and so on and so forth. And based on that node type, it's going to then call the methods on the renderer, like create element, create text, or create directive instance. Now the rendering engine ahead of time does not have an idea of what features of Angular you are going to use. So whether you are going to use internationalization or whether you are going to use pipes or SVG. So the rendering engine is designed to consider or to handle any template data structure that it gets. What that would do is that the rendering engine will have to include all the implementations of these methods, because it doesn't really know what it's going to get eventually at runtime, right? And that's why the framework code itself is harder to tree shake at this point with the view engine. Now, how exactly is Ivy going to fix that? What Ivy is going to do and how it works differently is Ivy transforms decorators to static fields. So you can just think of decorators being added on classes would mean that there is a static field that's going to be patched to the generated class file for that particular class or for that particular building block in Angular, so to speak. So if there is a component decorator that you use, then Angular compiler is going to attach an ng component def static field to the generated class code. For a directive, it would be an ng directive def. For an injectable, that would be an ng injectable def, and so on and so forth. So with this, the template compiler is now going to transform your HTML templates to instructions the way it used to work in with the template compiler. And then there is a runtime component that's again going to be responsible for rendering and change detection. So Minko also mentioned that there's an ng factory file, a component JS file, and several other files like the metadata file and the ng summary file that gets generated, right? With Ivy, that's not really going to be the case. With Ivy, there's just going to be an the component.js file that gets generated along with the component.d.ts file. Now, with this is just going to be as simple as the way the template compiler used to work. So you'll just get the template. Those will be compiled to template instructions, and then those will generate the DOM. And this is how the compiled code from Ivy looks like. Now it's much more readable. That's the first thing. It's also smaller as compared to, or it's not as cryptic the as the view engine code used to look like. And we can clearly see there are a few things that are going on here. So there's a type which is just the token for your component. There's a selector that is the CSS selector that you actually use in your templates when you want to render the child components or something. There's a factory function as well. Now this factory function is going to be responsible to generate the instance of this particular component. There are a few constant and variables, and the main thing here is this template method. So the template method has the definition of the components template, and it's going to determine whether it has to render it initially or it has to detect changes at runtime. And that's also something that is determined by this RF thing. RF here stands for rendering flag, and this would determine whether it has to initially run or it has to detect changes. If the value of RF is 1, then it has to initially render this template. If the value of it is 2, then it has to detect changes, and that's what these two if blocks are doing right here. And there is the CTX, which is the component instance that gets created. And now we are seeing some theta thingy right here in several lines here, right? So these are the IV instructions. There are a lot of things that are going on here. So it has to create things like an element, it has to create some text nodes, and it has to close those elements and text nodes as well. So these are the IV instructions that are actually responsible for doing that. So Angular uses the IV instruction set. What that would mean is that now the rendering engine that initially used to look something like this for the view engine can now be broken down into those smaller and more granular IV instructions. And there's an IV instruction for almost everything that is related to these templates that you actually use in your Angular application. So there's an IV instruction set for change detection, for pipes, for containers, for dependency injection as well. Now, how that would be helpful is whenever the template sees that there are a few IV instructions that you are going to use, the bundler is now actually going to be able to tree shake the remaining part of the framework code that you are actually not using. So if you are just using these fewer sets of rendering instructions or the IV instructions, then it's going to just add these instructions to the bundler, and the remaining implementation of the Angular framework code is going to be tree shaked from the final bundle. And there is another thing that we previously discussed, and that is regarding ngif. So here you don't really see those view container ref or template references right here, right? That's just the ngif or the child component that's been referenced in the directives array right at the bottom, right there. So this is something that Angular likes to call locality. And what that would mean is, if you want to refer to any dependency, then you can only do that using a clean public API. So since ngif had the view container ref and template ref, and it was an implementation detail that needs to be private, so that is something that you won't really be referencing in the generated code for your component. Now you might think, where exactly is Angular going to determine what ngif is going to look like, or how is it going to get generated? So for this, we have the ng component def static field. Just similarly, for the ngif, we will also generate an ng directive def, and this is going to have a similar implementation like the one that we have here. It's going to have a factory function that's going to basically return a function, and this here we are using the iv inject instruction. And if you are aware of Angular's dependency injection, this is how exactly you can visualize the inject instruction to be like. So the inject instruction takes a token, and that it returns to you the dependency of that particular token type, and that is something that is then passed to the ngif while creating an instance of it. So this factory function is going to be now responsible for creating an instance of that ngif, and not your component definition itself. So with that, we will be able to solve a lot of design goals that Ivy had in mind when it started when the Angular team started building Ivy. First one is optimizability. So now the framework code itself would be tree shakeable, as we have already seen, and you won't really have to pay the whole cost of the whole framework if you're not using some parts of it. If you're using only specific parts, then only those specific parts and the code related to them would be bundled in the final bundle. So that would lead to smaller bundle sizes. Then it would also lead to incrementality. What that would mean is that now the Angular compiler or your code is not going to trigger a global compilation. It is going to only compile the Angular component that you have created. It is not going to compile the ngif as well again and again. So faster builds and less time. Final is flexibility. So you have already seen the code that gets generated, right? It's really simple and easy to understand. So it is also easy to reverse engineer, and it also opens up avenues for things like higher order components and meta programming. I have a StackBlitz link right at the bottom of this slide. So once I share this slide with you guys can check how higher order components and dynamically loading of component can be done. And one last thing is the JavaScript distribution or the size contribution that you're going to see as of now. As of now, uh, Ivy is in opt-in preview mode. So what that would mean is it's not there by default. You will have to switch a flag, and then only Ivy will come to life. So with that, Angular team is also currently working hard to make it backwards compatible. What that would mean is that you won't really be able to see any specific framework code as of now being tree shaked, but the remaining template code is going to significantly reduce. So in summary, we talked about the template compiler, the view engine, and how Angular is for the win. And I'd like to especially give a vote of thanks to all the partners with the help of whom this workshop or this session is sponsored. And yeah, I guess that would be all. Thank you so much. And here is a list of few resources that you might want to check out if you want to learn more about Ivy. Thank you.